Okay, here we go. Number 2 says point Q is on MN such that MQ to QN is 2 to 3. And it says if M has coordinates of 3, 5, and this is M, and N has coordinates at 8, negative 5. That's N. They want you to determine the coordinates of Q. So I'm going to go ahead and connect M to N. I'm going to come back up here. And if our ratio is 2 to 3, that means we want 5 equal parts. With 5 equal parts, we can't use midpoint. Midpoint will only divide it into 2 equal parts, right? Or 4 equal parts, or 8 equal parts. And so we're going to try to use slope to divvy up our line segment. So here we go. In order to do slope, we'll say M equals M for slope, y's to the sky, and remember that we're subtracting them, all right? And so we're going to take our y's, which are 5 and negative 5, and we'll subtract them. So I'm going to do 5 first, then minus my negative 5. Because I chose that order on top, I have to start with the 3 minus my 8 on the bottom. Okay. On the top, 5 minus a negative 5 is really saying 5 plus 5, which is 10. And 3 minus 8 is negative 5. And remember, slope must always be reduced. If you do 10 divided by negative 5, you end up with negative 2. Okay, or you can say negative 2 over 1 so that you have a rise and a run. So negative 2 is my rise, and 1 is my run. So in order to rise down 2, I have to start at M, and then I will go ahead and rise down 2 and run 1 and put a dot. Down 2, run 1, down 2, run 1, down 2, run 1, down 2, run 1, and I end up on N, and so that's a good checker. Now I just have to make sure I have 5 equal parts. So 1, 2, 3, 4, 5 equal little segments in there. So we're good. And now we just have to read what direction we're coming from. So we want MQ to be 2 equal parts. So because I have M, I'm going to run 2 equal parts. That leaves me right here for this to be Q, so that QN is 1, 2, 3 equal parts. And so everything looks good, and now we can go ahead and state the coordinates of where we put Q. And Q is at, let's see, 1, 2, 3, 4, 5, positive 1. And that is the point on the directed line segment that divides MN into a ratio of 2 to 3. All right, number 3. It says, what are the coordinates of the point on the directed line segment from K, who's at negative 5, negative 4, and that's K, to L, which is at 5, 1. Okay. That partitions the segment into a ratio of 3 to 2. So again, 3 to 2 would be 5 equal parts, and that's not possible with midpoint. And so we're going to go ahead and use our slope as our backup. And so our slope, remember y's to the sky, so take our y coordinates and make sure that they go on top. So we're going to have a y coordinate of negative 4 and 1. So I'm going to take the 1 first. So 1 minus negative 4. And then because I chose that order on top, I have to go ahead and start with the 5 first on the bottom, then minus my other x coordinate of negative 5. All right, 1 minus a negative 4, same thing as saying 1 plus 4, which is 5. And on the bottom, 5 minus a negative 5 is the same thing as saying 5 plus 5, which is 10. And 5 divided by 10 reduces to 1/2. And so 1 is my rise, and 2 is my run. And so in order to rise 1, I have to start at K so that I can rise 1 and run 2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. And I end up right on L, so that tells me I did a good job with my slope. Now to make sure that it's 5 equal parts, but there's 1, 2, 3, 4, 5 equal line segments. All right, so now we're looking for which one do they want. They want to come from K. So K is my start, and they want me to go 3 equal parts. So 1, 2, 3 equal parts puts me right here, leaving 2 equal parts to the finish at L. All right, and so this is the coordinate that they want. and that coordinate is, let's say, +1, -1. And that is the point on the directed line segment that comes from K, goes to L, and divides it into a 3:2 ratio. All right, let's take a look at the next one. Now it's got a big graph. So in number 4, it says point P is on segment AB such that AP to PB is 4 to 5. It says if A has coordinates at 4, 2 and B has coordinates at 22, 2, determine and state the coordinates of P. All right, so we're going to go ahead and figure out, there's no axes on here, so we have to figure out where to put them. But we have to go from 4, 2 to 22, 2. So let's see how many lines are in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And we have to go 22, 2. So I think, let's go ahead and just put our line here. There should be 22 to go. And 22, 2 and 4, 2. So I don't think it matters where our x-axis goes. So let's see if that works. If not, we can always change it. All right, so I'm going to go ahead and graph A, who's at 4, 2. 1, 2, 3, 4, 2. And B, who's at 22, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 2. There's B. Yeah, it's a nice straight line segment. That should be easy, I think. Possibly. All right, so we have A who's at 4, 2, and B who's at 22, 2, and we have to determine and then state the coordinates of P. And so back up here, we're looking for 4 parts and 5 parts. So we need 9 equal parts. Again, that is not something that we can do with midpoint. So we're going to go ahead and deal with slope, but slope is going to go ahead and give me a 0 since this is a horizontal line, and it's not going to give me any rise over run. So we have to figure out a different way of dividing this line segment into 9 equal parts. So let's figure out how long is it right now. So if we start at 4 and we go to 22, so this is how many parts are in here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 in there. So I think if there's 18 line segments and we need 9 equal parts, that would mean each line segment is 2 equal parts. So let's go ahead and go 2 equal parts and put a dot. And let's see if this works. So a little unconventional from what we've been doing. We almost had like a problem where we actually had to kind of use our heads and solve it. So let's see if that is 9 equal parts now. So 1, 2, 3, 4, 5, 6, 7, 8, 9 equal parts. All right, so now that we have that done, they're asking for AP. So we have A, and if we start at A and we travel 4 equal parts, that's 1, 2, 3, 4. We're looking at that point right there, and then there should be from P to B, 1, 2, 3, 4, 5 equal parts. And so we found it. And so we're looking for coordinates of P, and P looks like it is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2. And there it is. All right, let's do one more question. Number 5 is talking about directed line segment PT. And it has endpoints whose coordinates are at P, which is at -2, +1. And T, who's at 1, 2, 3, 4, +7. Determine the coordinates of point J that divides the segment into a 2-to-1 ratio. So a 2-to-1 ratio means 3 equal parts. And again, that's not something possible with midpoint. So we're going to go ahead and try slope. So with our slope, we're going to go ahead and remember y is to the sky. So we have 7 as our y-coordinate minus 1 as our y-coordinate. Because I started with 7, I have to start with the 4 on the bottom first, and then minus 4 minus -2. All right, clean up the top. 7 minus 1 is 6. 4 minus a -2 is the same thing as saying 4 plus 2, which is also 6. And 6 divided by 6 is 1. If you want to make it a fraction, so you can talk about rise over run, you can put 1 over 1 and not change it. And therefore, 1 is the rise and 1 is the run. Okay, I forgot to connect my 2 points here. And all we're going to do is go up 1, rise 1, run 1, rise 1, run 1. And we have 1, 2, 3, 4, 5, 6 equal parts. Okay? Except we only needed 3 equal parts. So what we're going to do is we're going to group every 2. So we're going to group these as 1 equal part, and then equal part, and those as an equal part. And now we have 3 equal parts. All right. And so we needed to determine the coordinate of point J that divides the segment into a 2-to-1 ratio. Now, it doesn't say who to come from and go to, right? It doesn't tell us the letters where we start from. And so what we're going to assume, which I hate assuming, is that because P came first, we're going to assume that we are coming from P. So since P is our start, okay, which I don't like assuming that. I wish this question was a little bit more specific, but this is how they put it on the exam. So we're going to travel 2 equal parts. So remember, we're grouped our 2 of our equal parts into 1 equal part. And so we're going to travel 2 of those, which puts us right here, okay, and then have 1 equal part to T. And so we're looking for the coordinates of this point called J. And J is at, let's say, 2. 1, 2, 3, 4, 5. 2, 5. And there's our answer. All right, hopefully that was a good enough example that you guys get the gist of how they ask the question and what to do. All right, remember, always try to use slope to divvy up your line segment. Once in a while, midpoint will work, but slope usually works way more than midpoint. Okay, all right, I'll talk to you guys and see you on the next day.